All right, so the first couple pages actually are just different operations between functions. So I'm not going to do one of each type, but on this first part, you could have multiplication, division, addition, or subtraction. And you're really just doing what it says. So if it says division, you literally just put one over the other. If you could simplify it, you will. In this case, you can't even simplify it. So if it wants h divided by g, you take h, 3a plus 2, and you divide it by g, negative 2a squared minus 4. There's actually no simplifying you can do there. If I could take a 2 out of everything, I would reduce it by 2. But I can't even reduce this one. This one's actually done. The next one says to subtract. So I'm literally going to subtract. I'm going to take the first function that it mentions, which is f, 2n minus 2. And I'm going to subtract the g function. I chose subtraction for a reason because this is the number one problem I see with subtraction, is that people jump to put parentheses around it, and then they mess up their positives and negatives. So remember, when you're subtracting it, you're subtracting the entire group. You want to distribute that negative through, and then combine your like terms. So I have 2n minus 2. A negative times the negative makes that a plus 4n. A negative times a positive makes that a minus 4. And so when I simplify this one, I actually end up with 2n plus 4n, which gives me 6n. Negative 2 minus 4 gives me a minus 6. And that one is done. So on that first page, you are literally just doing what it says. I do want to point out that multiplication will look like a closed little dot. Composite, which is what we're about to do, will be an open circle. So those are two different things. This closed dot means to multiply, which means if I have two groups, I'm going to FOIL the two groups, okay? Composite means to put one group inside the other, okay? So the open circle means take the one group, put it inside the other group. The closed dot means multiply, which is what you've been doing forever, which is just like foiling. All right. So if you flip to the second page, then when you actually get an answer. So if you have a composite and it still has a variable in here, your answer is going to be a new function. It's not going to be a number. Okay. If it has a number, then there's two ways you can do it. Okay. And so we're going to do those two examples. So this first one wants g of h, which means I take h and I put it inside of g. So I'm going to take this h, and wherever there is a variable in g, I'm going to put it in that place. So g is 4a plus 4, but I'm doing g of h. So 4, and instead of a, I'm going to write the entire h function, which is a squared minus 5a. And so this guy is 4a plus 4, so I need to say 4 times the function plus 4. Okay, I've just filled it in. And I am going to simplify. So I'm going to distribute that 4. 4a squared minus 20a. And don't forget, you still have a plus 4. If I could combine any like terms, I would. In this case, I don't have any like terms. I'm actually done with that composite. Put one function inside the other. All right. Now, when you have a number there, you don't have to do it this way. You don't have to put one function inside of a number. You can actually put the number into the first function and then put it into the function in front. Meaning I can take this 6 and plug it into g. And then I can take that answer that I get and plug it into h. All right? So when I have a composite with a number, my final answer will be a number. You always start with the function closest to the number, in this case, g. So I'm going to take the g function and I'm going to plug in a 6. So n squared minus 1, I'm going to plug in a 6. 6 squared minus 1. Well, 6 squared minus 1 is 36 minus 1, which gives me 35. Now I'm going to take that answer and plug it into the first function that it listed, which is the h. So I'm going to take that and say 3n minus 2, and I'm going to plug in the 35. 3 times 35 minus 2, all right? So for this one, 3 times 35 is going to give me 105. 105 minus 2 is going to give me 103, and that is my answer. Now, if you had done it the way we did on 11, putting g into h, you would say h is 3n. Well, n is going to be replaced with that function, minus 2. You would get 3n squared minus 3 minus 2, 3n squared minus 5. And then you would have done 3 times 36 minus 5, which would still give you 103. All right? And so you can do it either way. You can do the composite first, and you will get the same answer, or you can just plug in the number into this closest function, plug the answer into the furthest function. So steps to solving. F of x is just y, so then change it to y. Switch x and y. I'm literally just rewriting it and writing an x where the y was, writing a y where that is. So I have x equals 1 over y minus 2 minus 2. Solve for y. That means get y by itself. Move anything over that doesn't have the y. Once I have this, if what I need is on bottom, remember you can flip both sides and then get y by itself. Once you have this, just rewrite it so that you have your inverse notation. So it says state if there are inverses, use function composition to show why or why not. So function composition means I am going to put one in the other and it doesn't matter which one. So I would probably put this G into the F. So I'm going to do composition just like I did on page 2, and I'm going to say 2/5, and instead of x, I'm going to write this 8x plus 4. All right? When you do that, you get 16/5 x plus 8/5. These are not inverses of each other. The answer here is no. And the reason is that when I take the composite, I do not get just an x, all right? If you were to do the composite of 25, your final answer would be an x. So if you look at 25, so if you look at this one and I do the same exact thing, if I take the composite, let's say I put G inside of F, -5, 1 minus 1/5 x, and then plus 5. If I distribute, -5 times 1 is -5. -5 times -1/5 is just positive 1x, and then I have plus 5. -5 and positive 5 zero out, I get just x. So F of G, that composite equals just x. That means, yes, these are inverses of each other, all right? So if you get just an x, it is an inverse. If you get anything else, x plus 2, x minus 2, 2x plus 3, it doesn't matter. If it's anything except just the variable x, they are not going to be inverses of each other. And you use composition to see if they are or if they are not. So remember, if it's something like this where it's compounded annually and they give you years, then you do not have to worry about how many times a year it compounds, okay? So your normal one is, okay, what my principal, whatever I start with, 1 plus my rate over the number of times it compounds, raised to the number of time it compounds times the number of years or times that it does that. So if it said compounded quarterly and then said in this many years, then you would have to divide that by 4 and raise it to the 4 times this, right? But if how they gave you the compounding and the time that they gave it to you in is the same, you don't have to worry about dividing by that number and all that, okay? It's only if it compounds differently. In this case, it doesn't, so we're just going to plug that in. We're going to say, well, my current balance is $1,455. So that's my starting amount. 1 plus my rate, 4%. We're going to say 0.04. Raised to the number of years, that's 13. All right, and so we're just simply putting in our starting amount. 1 plus would be growth, 1 minus would be decay. And then you just plug it in and you'll get your remaining balance. Remember, for dollars, we want it 2 decimal places, dollars and cents, all right? If we look at the next one, we're talking about a vacuum and it says removed. This should indicate that it is decaying, all right? If they are removing something, removing the amount of dirt, then that is the decay. It says each pass is 15%, and how many passes? 7. So those are the same. So there's no division that happens. Our initial amount is 14, so we would say 14. They gave it to you with 2 decimal places, so likely your answer will be in decimals. And I will tell you in the problem how I want you to round it. But instead of adding, I am going to subtract that. It was 15%, so we are going to say minus that 15. We're going to subtract that out. So we're going to say minus 0.15, and we are going to raise it to the 7th power. All right, so when it's decay, you're subtracting. When it's growth, you're adding. All right. And you'll put that in, and it's, again, they gave it to you with 2 decimal places, so you want to match that right there. 2 decimal places would be 4.49 ounces. Writing. So these should be really easy. If I want you to rewrite it to exponential form, that means I want this number 35 group to look like this group. And if it says rewrite to log, I want you to make this group look like the log group. You're just rewriting. Your bases will always be bases. So this is my base. It will be the base of my exponent. So that's going to be the base of my exponent. This piece is my exponent. So I'm going to say 9 to the x. And that's going to equal that 59. 9 to the x equals 59. So that's rewriting it in exponential form. For this next one, I'm rewriting the other way. This is my base. So that's going to be the base of my log. So I'm going to say log base u. This piece is what I am taking the log of. And this is going to be what it all equals. It always equals that what was originally the exponent. Any questions? So then this last piece is just saying rewrite it to exponent and then evaluate. So I'm going to set that equal to an x. Remember, this is my base. This is my exponent, and this piece is what it equals. So now I have to figure out 36 to what power equals 6. There's 2 ways to do this. You can either automatically know it takes the square root, or you can rewrite this to the same base. This is base 6. So I can rewrite 36 as 6 squared. That is 36, right? 6 squared to the x equals 6 to the first power. Properties of exponents tell me to multiply these. So that's 6 to the 2x equals 6 to the 1. Once I have bases the same, I can actually say that my exponents equal each other. So since my bases are identical, I can say 2x equals 1, divide both sides by 2, x equals 1/2. If you happen to already know that 6 is the square root of 36, and you know that's as a 1/2 exponent, you can go straight to it. Or you can simply figure it out with setting those to same bases. Using my properties of exponents, I pulled my exponent out first and put it in front. Then I split up the division using subtraction. So I went from 1 log to multiple logs using subtraction there. Then I expanded this exponent with a 4 in front. So I put this 4 in front. And the last piece, since this 2 applies to all of it, I just distributed the 2 through. The 2 in front of this and the 2 in front of that. So when I am condensing, my final answer should only have 1 log in it. So when it looks like this, I'm actually going to rewrite this one so that it's a 1/3. Anything over a number is like having the fraction in front of it. So that's like 1/3 log base 9 of 8 plus 1/3 log base 9 of 7 plus 1/3 log base 9 of 3. Okay? And they multiply them out. I'm not going to actually make you do that. This 1/3 is applying to everything just like this 2 did. So technically this is 1/3 times all of these logs. They're all being multiplied by the same thing. So you can actually think of it this way. That 1/3 applies to all of them, so we can look at that at the very end. How do I condense addition? Well, it's multiplication. So I'm going to say, well, that 1/3 is being applied to log base 9 of 8 times 7 times 3. All right? And you don't have to multiply the 8 times the 7 times the 3, because that could just as easily be an x, y, and z for all I care. Your answer key, I think, did multiply those, but you don't necessarily have to. Remember that a fractional, this is actually going to become the exponent, right? This is going to become the exponent on all of those. Fractional exponent is just a radical. So log base 9, and that is a root with 3 as the index of 8 times 7 times 3. And you can leave it like that. I think your answer key has 168, but I'll take either one of those. All right, solving is going to be, at first, very much like you did earlier. You want to look for a common base. So these actually have a common base. 216 and 36 have a common base. Anybody know it? So I can rewrite 216 as 6 to what power? Yeah, to the 3rd power. So that's 6 cubed to the 3b, right? And how do I write 36? 6 to what power? Yeah, 2nd power. And so you're looking for common bases is what you're looking for. Property of exponents tell you to multiply. So 3 times 3b is 6 to the 9b. Here you need to distribute that 2. So I have equals 6 to the 6b minus 6. All right. Once you have your bases exactly the same, these exponents equal each other. And that's how I'm going to solve for that variable. I'm going to say, well, then 9b has to equal 6b minus 6. And now I have a really easy problem to solve. I'm going to subtract my 6b. I get 3b equals negative 6, and then I'm going to divide by 3. b equals negative 2. And that is my answer. This says to use properties of exponents. So before you even think about what you're doing here, break this one up. This is division, right? So I'm going to spread it out just like I did expansion. Since this is division, I'm going to say, well, this is log base 3 of 1 minus log base 3 of 7. Here's a little hint. Log of any base of the number 1 is 0, because anything to the 0 power equals 1. Okay? So anytime you have any log, any base of the number 1, this piece right here is going to equal 0. So I have 0 minus log base 3 of 7. They gave me log base 3 of 7. What is log base 3 of 7? Well, they said it's 1.8. So I have 0 minus 1.8. My answer here is negative 1.8. So they're going to give you something over here that you can use to solve this, whether it's breaking it up by subtraction, and I use the 1, or if they had said 4/7. Log base 3 of 4/7 would have been log base 3 of 4 minus log base 3 of 7, and they gave me both of those. So you're literally just expanding and then using the pieces they gave you to give me the answer. All right? Remember on my calculator, I only have 2 bases that are naturally built into my calculator. I have a base 10 and a base E. All right? So I can convert any other base using those. If I have some other base of a number, then I can use my common log or my natural log, actually, of the large one, the one I was originally finding, divided by the common log of my original base. And that will give me what that equals. If they want log base 7 of 28, I don't know log base 7 of 28, and 28 is not a number that 7 naturally is a base of. It's not like it's 49, something that I can naturally say it's going to be 2, right? So I can use my change of base. I can say, well, this is going to equal my common log of 28 divided my common log of my base. All right? And then it says to nearest thousandth, that is 3 decimal places. So you can just plug that in and round. You are going to use conceptually the same thing at these next ones. I actually pulled one that was a base 10. They're not all going to be base 10s. You might have to use common log or change of base. But when you have something like this, you're going to use log to get rid of it. So I'm going to get my base by itself first by subtracting that 4. 10 to the n minus 5 equals 21 minus 4. And then I'm going to take the base of both sides using logarithm. In this case, it's base 10. So I can just do my common log of both sides, all right? Common log of both sides. Bases cancel out bases. Had that been 7 to a power, I would have been log base 7. Had that been 6 to a power, I would have said log base 6, okay? Bases cancel out bases. This was a base 10, so I used a base 10 to cancel it out. On the left-hand side, those just cancel. And I am left with just that exponent of n minus 5. On the right, I have log of 17. Now I have a really easy problem. I just add 5 to both sides. And so my n is going to equal log of 17 plus 5. Make sure you close parentheses in your calculator. Make sure you open close parentheses there. It says round to the nearest 10,000th. That is 4 decimal places. So this is going to be approximately 6.2304. So this is conceptually the same thing. Bases cancel out bases. I need to get the log by itself. So I have to subtract a 5. I have log base 12 of a minus 8 equals negative 2. What exponent base do you think I'm going to use here? 12. So 12 to this power equals 12 to this power. My base 12 canceled out my base 12 on the left. I just have a minus 8. Over here I have 12 to the negative 2, which you can do. That's just 1 over 12 squared, 1 over 144. But you can do it in your calculator. My final step in solving here is to add 8 to both sides. So my a is going to equal 12 to the negative 2 plus 8. Again, you can do that in your calculator. It is going to be a decimal. Again, nearest 10,000th. You're going to get 8.0069 here when you plug that in. The difference between this and the other one, granted your answers are in fractions, but I will likely ask for these in decimals as well, so that's fine. But the difference here is that you have multiple ones that are there, okay? You have to have one log before you can use a base to cancel it out, okay? So I need to condense this first. I cannot use a base to cancel out a base when I have multiple logs. You have to condense it first using your condensing. So I have a subtraction here. How am I going to condense these? How do I condense subtraction? Division. So I want to rewrite this to 1 logarithm base 5 of 2 divided by x minus 3. All I did was condense it. Because that's subtraction, I did division here. All right? Now that I have 1 log, bases cancel out bases. I can do a base 5 here and a base 5 here, all right? On the left-hand side, that cancels my log. I have 2 over x minus 3. On the right, I have 5 to the first power, all right? So now 5 to the first power is just 5, but I wanted to write it out because sometimes people forget. Anytime what you're solving for is on the denominator, what can you do to both sides? Flip both sides, all right? So we are going to flip both sides. It's going to make your life a little easier. I have x minus 3 over 2 equals 1 over 5. And now I'm just solving. I always get rid of this guy first. Multiply both sides by that 2. Those cancel. X minus 3 equals 2/5. And then add 3 to both sides. X equals 2/5. 3, if I were to get a common denominator, is 15/5, right? 15 over 5 is 3. So 2/5 plus 15/5, my answer here is 17/5. Remember, this formula is actually easier than the other one. What I am solving for, my account at the end of this, will be the principal, or my starting amount, times e to the rate times time, right? It says the savings account is compounded continuously. This is what tells you you're going to use this formula with an E. Interest rate, that's my R. Per year, the current balance, that's my starting. What will the balance be? 10 years, that's my T. So I'm just going to plug it in. 1,914 times E to the rate, 2% is 0.02, time is 10. This is dollars and cents for this one, so we want to round to dollars and cents, even though your directions say tenth. That does not apply to dollars and cents. All right? If it decays, then you are going to have one less, it's going to be less than 1. So you're going to actually have to do a rate that is not 0.02 there. You're actually going to have to do a different rate there. So these are all growth. So again, make sure you have a calculator, 194, and you're going to do multiply. You're going to hit that E button and it's going to automatically open parentheses. You want to put the 0.02 times the 10 in parentheses and close it.